Hi again, and welcome to the third episode about our series on SSI applications brought to you by Internet of People. Now things are going to get really exciting because we're going to dig a bit deeper into this Hydra blockchain. On this slide, we summarize our technology stack again, and you can see that the Hydra blockchain resides on layer 1. Layer 1 is built on top of a communication network typically called layer 0, and for us, this is the internet. Additionally, we also use materials from the cryptographic key vault, which is one of the important parts of our SDK. So the Hydra blockchain is a necessary building block in order to enable a self-sovereign identity system, because we need a place where we can securely store decentralized identifiers and methods attached to them. If you have never heard about blockchains, I'm trying to give you a basic primer on it, but don't worry if you don't understand everything. It takes a while to grasp your head around everything. So now imagine a network of computers, and on top of each computer, the same software is installed. This software enables the computers to get new transactions and include them in a new state. So let's make it a bit more concrete. Imagine Alice and Bob, and each of them have a certain balance within the network. So this balance is depicted by Hydra, which is the Hydra token on our blockchain. And the primary state depicts Alice having 10 Hydras and Bob having 12 Hydras. So this is, so to say, the first block. Now imagine that Alice wants to send Bob 1 Hydra. The way she does it is by sending a transaction to one of these computers, and now this transaction will get distributed across the network. The software allows the computers to agree upon the next state, and once this happens, each of the computers agrees that Alice has 9 Hydras and Bob has 13 Hydras. So now on the screen you can already see what I mean by a blockchain when you have 2 blocks which is chained together. In reality, a blockchain consists of many hundred thousands of blocks, but this is obviously a bit hard to depict on a slide. Let's now see how this transaction thing works. So let's consider a transfer transaction, the same as before, where Alice sends Bob 1 Hydra. Here you have Alice and Bob, and both of them have an address generated by this cryptographic key vault, which is compatible with the Hydra blockchain. Now Alice will create a new transaction in which she will specify the recipient of the transaction and herself as a sender. The amount contains 1 Hydra because she wants to send 1 Hydra token to Bob, and it has a nonce which mitigates double spending. Double spending means that Alice would spend the same transaction twice. In order for her transaction to be included, she also pays a fee for the computers within the network. Now she will sign the transaction with her private key in order to show that she is actually authorized to issue this transaction. Next, she will send this transaction together with her signature to this network of computers which run the Hydra blockchain software. Now, these computers will interact with each other and arrive to a final state in which the transfer is confirmed if everything is valid within the transaction. Now, let's have a look at the fundamental properties of blockchains that makes these technologies so interesting. The first one is that it is trustless. This means that there is no need for a trusted third party in order to process transactions or generate a new state. Previously, in financial systems, we always needed a bank, but this changed with the rise of Bitcoin. The second property is that there is no way to do double spending, and this is especially important in this digital age that we live in, where copying and pasting something is very trivial. This means that Alice actually cannot send the same transaction twice. An additional property is that the contents of the state and the transactions become immutable after a while. So Alice, or for that matter, anyone, has no way of changing the transactions once it is included in the blockchain. The next important property is that there is no single point of failure. This means that a person, a nation state, or even a natural disaster can occur and the system will still not be shut down. The final property of the blockchain is that it is fully transparent. Here, I mean that anybody can verify whether a blockchain has derived the correct state from the incoming transactions. Now that we know about the fundamental properties of the blockchain, let's have a look at our Hydra blockchain and what makes it special. First, it is a delegated proof of stake network, which means that for each round of communication, 53 delegates are picked from within this computer network. These delegates are tasked with including new transactions and generating and agreeing upon the final state. If they act according to the rules, they are rewarded with the transaction fees, but if they act maliciously, they lose their forger status and their good reputation, which means that in the future nobody is going to vote for them, thus they will stop earning rewards. This incentivizes them to do the good thing. Our Hydra blockchain is fully public. This means that anyone with a computer or an internet connection can join the network. Transactions can contain arbitrary data. This means that also identifiers can be included, which we need to build a self-sovereign identity system. The Hydra blockchain has three networks. The mainnet is a production-ready blockchain on which real value is transferred. The DevNet is a developer network on which developers can create and test applications without having to fear that they lose real money. The testnet is for local testing only. Here, we test new features and see if they work without breaking the system before we deploy them to the DevNet, where then additional security audit can determine if it can be finally ported to the mainnet. Now, I think it's time to look into a real Hydra transaction. For this, we can go to hydra.iop.global, which contains a block explorer. Here you can see the block explorer, which allows you to check the transactions and the blocks. So here I selected a transfer type, but you can also have different kind of transactions here. We will encounter different transactions later on, but let's not now focus on the basic one, the transfer. If we go to one, we can see the same information we saw before. You have a sender, a recipient, a transaction type, here the transfer, the confirmations. This is the amount of blocks that have been forged since this transaction took place. The fee which was paid to the forgers or the delegates, and the amount of Hydra that was transferred. And you have some additional information, but I think we covered the most important ones. And therefore, I would like to invite you to watch the second part of this episode where we will fill our Hydra address that we generated in the previous part with test Hydras. See you there.